In this section, we're going to solve systems of equations. So we're going to start with two equations and two unknowns, and we're going to review the methods of substitution and elimination with a couple problems and see what the possible solutions may be. So first, let's look at this. 2x minus y equals 3, and 5x plus 4y equals 40. Okay, so we have two equations and our unknowns are x and y. And so our final answer, we're hoping to find what x equals and as well as what y equals. All right, so the first method that we're going to look at is substitution. And when we use substitution, basically we're going to find an equation. One of the equations, we're going to take one of the variables and solve for it, and then we're going to substitute that variable into the other equation. So the reason I chose substitution on this problem is that I kind of have this y, it's a little bit more alone than the rest of the variables. See, this variable is 2x, this is 5x, and then 4y. What I'm looking for when I'm using substitution, usually I want to have a variable that's either alone or almost alone. So this is just negative 1y. So it's a little bit easier to solve for. All right, so we're going to solve for the y in equation 1. And I usually like to number my equations. That's going to be especially helpful when we have 3 equations and 3 unknowns. So I'll just start now by numbering my equations. So if I want to solve for y, I think I'm going to add the y to the other side. So that would be 2x is equal to y plus 3, and then subtract the 3. So y is equal to 2x minus 3. Okay, now I'm going to take that y equals 2x minus 3, and I'm going to substitute it in for y in the second equation. So now I'm doing substitute for y in equation 2. Okay, so I have 5x plus 4, and then that y is 2x minus 3. See, I'm taking what is equal to y and plugging that in. And then that's equal to 40. So now notice that I actually have one equation now, and it is all in terms of x. So now it's just a matter of solving the linear equation for x. So I have 5x, I'm going to distribute the 4, so plus 8x minus 12 is equal to 40. Now I can combine 5x and 8x to 13x minus 12 is equal to 40. Add 12 to both sides, so 13x is equal to 52. Divide both sides by 13, so x is equal to 4. Okay, so great. I got x to be the number 4, and then I do need to go back and find y. Well, I actually have y solved for, so that's the easiest place to find y, but you can plug it into either original equation as well. But if I do it here, y is equal to 2x minus 3, so 2 times 4 minus 3, and y is equal to 8 minus 3, or 5. Okay, so in other words, my solution is 4, 5. It's a point, x, y, and it's 2 lines that are intersecting in a point. Let's take a look at another example. And this time we're going to use elimination as the method. So our problem is 3x plus y equals 10, and 9x plus 3y equals 13. This would be a fine problem for substitution or elimination because see, I have this y here, So I could easily solve for it and use substitution in the second equation, but it's also, elimination is really good for any problem pretty much. So we're going to use elimination method for this problem. So remember that this is equation 1 and this is equation 2. What I'm going to do is multiply one of the equations or both of the equations by a number that will give me the opposite number, the opposite coefficient for either x or y. Okay, so if I'm looking in this equation, probably the easiest thing would be to multiply the first equation by -3. The reason being that -3y plus 3y, if I add those together, I'll get 0. So I want the opposite, look for the opposite coefficient. Okay, now when I multiply by 3, -3, I actually have to multiply every single number by the -3. Okay, so my first equation is now -9x plus -3y is equal to -30. And I could have just written minus here, right? Okay. And then my second equation, I just leave it as 9x plus 3y equals 13. Okay. Now that I have an opposite coefficient, I can add the two equations together. So just write them right underneath each other with the same x's in a line, in a column, y's in a column, and then on the other side of the equation, the constants in a column. All right, so when I add these, you might have already noticed, these are also going to eliminate each other. So this is 0, this is 0. So on this side of the equation, I have 0. On this side of the equation, I do not have 0. So that is -30 plus 13 to me looks like -17. Okay, so we did elimination correctly, but we were not able to solve for x and y. And in fact, we got an untrue solution, not true, right? So if we get a not true solution, then we actually have no solution is the answer to our problem. Okay, so when you get 0 equals -17, that's not your answer. Okay, in fact, no solution is your answer. And what's happening there is, and we're going to look at some pictures in a minute here, but the lines are not crossing, so they never do have an intersection point.